Greetings to all you exquisitely inquisitive ladies, gentlemen, and scholars, and welcome to Natural Philosophy with J. Allen. In this episode, I shall be giving you a brief conspectus of what we've learned thus far in regards to the peculiar, mystical, mind-expanding, paradigm-shifting world of limits. And as you can see from this wonderful pictorial here, that when you're thinking about limits so much for so long that obviously, as you can see, this person's head exploded. And most likely this will happen to you, but I assure you that you'll have so much fun along the way. And yes, you heard me right. I said mystical. Many of you serious mathematicians out there are probably going to shake your fist at me or your canes and say, there's nothing mystical about calculus. But I beg to differ. Anytime you're dealing with infinitesimally small areas of space, you're going to see a breakdown in what you know of as reality. I assure you of that. All you need to do is crack open a book of quantum mechanics and you will see well-respected physicists speaking of the vastly tiny realm of the quantum as a place of absurdities and strangeness. And so it is even more so with limits, because when you take a limit, the x value is never static, it's never just chilling out in one location. No, it's continuously traveling towards its destination forever and ever. You see, it's not just hanging out right here at 0.00, really small number. No, it's getting smaller and smaller and smaller forever. Infinitesimally small means that it is infinitely getting smaller. It's never going to reach that point because the distance in space is always getting smaller. You can always cut a distance in space in half. You can always take a fraction of a distance. And that's what's happening. We're dividing the distance in half, or in quarters, or even smaller than that. We're always dividing the distance, you see? And when you have something that's getting smaller and smaller and smaller forever, strange things are going to be happening. You're going to have a point at one location. You're on the threshold of zero, but you're never going to get there. You're right at the threshold. All of this, because it's infinitesimally going towards that destination. It's there at that destination, and yet it's not. It's in two places, or infinite amounts of spaces simultaneously, while also being at its destination. That's what happens. It's a breakdown of reality as we know it. And yet the mechanics of what you're actually doing here is absurdly simple. All you have to do is assume that the x is 0, because it is 0. It's 0, and simultaneously it's an infinite amount of really, really small points, but it is also 0. So you can assume, yes, it's 0. You're not really assuming, it is 0. It really is. So you plug 0 into the x. You just shove that 0 into the x. And you get 0 squared plus 2. And there you have it. It's that simple. Obviously, that will equal 2, right? And so again, ridiculously simple. And yet, when you think about it long enough, your head will explode. So let's think about it some more, shall we? So remember this graph here? We've seen it before. This is a secant line. So when x plus h starts moving towards the initial position, which is x sub 0, right? Remember this? As x plus h gets closer and closer and closer to the initial position, then the q, this point will get closer and closer and closer to P. So the secant line will get smaller and smaller. See? You see how that happened? You move the point here, and the line suddenly gets smaller. And if you move the point, first you have to move this point, of course, and then when you move this point gets smaller. You plug something into the x value, it'll change the y value, the f of x. So as this gets smaller, this is going to get closer and closer and closer to this point. And this is where things get really weird, because as it gets closer, you should know that it will never be that point. It will always forever and ever and ever simply be coming closer and closer and closer to that point. Because once it gets to that point, you have a zero. You have a zero distance. It's getting smaller and smaller and smaller till it reaches zero. And you cannot ever, ever, ever have a zero. Why? Because that h will be a zero. And there's a problem there. If you put 0 in that h, it won't work. So because it's moving infinitesimally close to that p, the q is moving infinitesimally close to the p, it is a line with 2 points, except that it is also simultaneously a zero. So you can look at it as both two things at once. There's a superposition going on here. This is how the quantum mechanics that I was explaining earlier relates. You're having a superposition of one single point and 2 points simultaneously. So because you have a distance of more than 0, you can plug that quantity in there. Because it's not 0, it's more than 0. And yet, the value is in actuality 0, and so that means you can legally plug the 0 into whatever function you're trying to solve for, and you will get an exact value, such as the function we were dealing with earlier. Plug the 0 in, and you get an actual perfect value of 2, not an estimation of 2, but the exact value. Because when you're dealing with limits, you have 2 points, and yet you also have 1 point. And so that is the incredibly weird, mystical, mind-expanding, paradigm-shifting world of limits. And so it is my sincerest wish and desire that you find this as exciting and as invigorating as I do, because personally, I am confident that everyone has in their being a love for the mathematics. When I was a wee lad back millennia ago, back in school, I hated, dreaded, despised with every fiber of my being mathematics. Arithmetic was so dull and boring and complicated to me, but the calculus is so beautiful, and I think deep down, every single person, if you really understood just how amazing calculus is, you would see that it is a wonderful design and creation. And don't think that it's a coincidence that the creator of the multiverse came into your universe as a man named Jesus and was the adopted son of a carpenter, or as the Greek says, a tekton, which could be any word that could be applied to creating with the applicable mathematics. So there was a lot of mathematics in that household. So clearly the creator has a love for the mathematics and a love for applying mathematics in a creative aspect. And creation shows that he has a deep love for the mathematics. So I believe that it is built and designed into the very fiber of your being that you love the mathematics. And so that's all we have for you today. If this video was helpful, then you can give it a thumbs up and of course subscribe. That would always be nice. So have a good day.